morning, students. So last class we discussed about what do you mean by a lathe machines and what is the different uses of the lathe machines and what are all the different components are in the lathe machine. We have discussed about the center lathe, we discussed about the automatic lathe, we discussed about turret lathe, capstan lathe, bench lathe, tool room lathe, all those things in the previous classes. Today's class we are going to see what are all the accessories are used in the lathe machine. The accessories are going to be supporting devices, which is used to perform the work effectively as well as efficiently. For that purpose we need some accessories for the lathe machine. So today's class we are going to see what are all the accessories are used in the lathe machine. So if you are going for the accessories, we should know what is meant by accessories. First we will see in this particular chapter. So equipments are the tool, the accessories are the equipments or tools used on the lathe to assist in performing an operation. It is assisting to perform the operations. What are all the accessories are available for the lathe machine? So many accessories are there. We will see very important accessories are used. So many accessories. Out of this we will see 5 or 6 accessories which are most commonly used in lathe machines. So if you are going for these accessories, there are two categories. One is going to be which is used for holding the workpiece. Another is for holding the tool. So if you are holding the work, we call it as work holding devices. If you are holding the tool, we call it as tool holding devices. If you are going for the work holding devices, which are used for supporting the works for driving, so those we call it as the work holding devices. In this category, the following components comes. So lathe centers, chucks, faceplate, mandrels, steady and follow rest, lathe docks, drive plates. And if you are coming for the cutting tool holders, or we call it as tool holders, there are going to be straight and offset tool holders, threading tool holders, boring bars, and turret tool post. Turret tool post we already seen in the turret lathe machine. How many tools? There may be 6 tools are holding on the turret. We will see one by one. What is meant by a lathe center? The lathe center or your center which is used to hold the workpiece in between the centers. The dead center is on the tail stock, live center is on the head stock. The workpiece is holding in between the centers, right? So the work turned between the centers must be have the central drill. A small hole will be drilled on the workpiece to insert the center. If it is small hole, this center will exactly hold, supporting during cutting. It will give the support, rigid support at both the sides. Most common having the solid Morse taper. Morse taper means it is uniform taper will be there. It acts as a self-lock. Uniform taper with the self-lock. How much is the taper angle? Will be the 60 degree, which is going to be the tip will be very hard. Otherwise, the center may get damaged. So because of that, the tips are made up of carbide, right? And for free rotation, it has to be lubricated occasionally. Whenever we need, we have to lubricate. That is the lathe centers, right? So if you are going for the centers, different types of centers are there. In the center itself, you have different centers are there. One is going to be a revolving center, right? And another is going to be a bearing operated centers. So like that, different types of centers are used in the lathe machines. So see, lathe center are supported end of the work. It is usually made up of carbon steel because it has to bear resistance. Otherwise, because of rotation, there may be some erosion will be taken place between the workpiece and the centers. So there are 3 types. One is going to be a live center, which is revolving along with the workpiece. Which is fixed on the headstock. Dead center and then half center. Dead center is on the tailstock. Half center is again used in the tailstock as well as in the headstock. So if you are going for this live center, see the live center, the construction is 60 degrees at an angle. This angle, if you are going for joining these things extended, it will be 60 degrees. Run on its own bearing. So why we are using the bearing? To reduce the friction. Live center fits on the spindle of the headstock. Always the live center fixed on the headstock and rotate on the spindle. Why used in turning between the centers? It is used when we are turning between the centers. That is what we call this live center or the revolving center. So next one is going to be how it is fixed. See there, this is going to be a tailstock. This is going to be tailstock. There we are fixing the threaded one. A chuck will be there, threaded chuck will be there. Then we are inserting the centers. Just because of taper, most taper, it is automatically fixed. Self-locking. We call it as self-locking. The next one is going to be a dead center. See, this is what we call as a dead center. This is what we call as a dead center. This dead center is also revolving. It just give only the support. Gives only the support for the work when the workpiece is held in between the centers. Held in between the centers. Right? This is half center. The half center is, that center is not complete. It will be in the curvature like that. It will be in the curvature like that. The half center is also used to avoid the more contact area. Provide more contact area to reduce the friction. Right? So for the half center. So these are all the three centers are used in the lathe machine. One is going to be a rotating revolving center. Another is going to be a dead center. Another one what we call it as a half center. Next we will go for the work holding. Another work holding device is what we call as commonly used in the lathe machines are different types of chucks. Different types of chucks. In this the first one what we call it as 4-jaw chuck. The second one is 3-jaw chuck. And this is going to be 6-jaw. So each and every jaw will have different usage. The first is used for doing offsetting workpieces, for offset workpieces where the workpiece is not regular shape, not cylindrical shape. For cylindrical shape, we will go for 3-jaw chuck, and again for symmetrical shape, we will go for 6-jaw chuck. We will see one by one. What is meant by a 3-jaw chuck? See there, 3-jaw chuck, how the workpieces are hold, how the workpieces are hold. For that purpose, I am showing how the workpieces are hold. This is 1 jaw, this is 2nd jaw, this is 3rd jaw. So 1, 2, 3. So solid workpiece will be held. Right, multiples of 3. 3 sides, 6 sides, 9 sides will be fixed on the 3-jaw chuck. And then if we are going to the bigger workpieces, diameter, right? If you want to go the perform the operation at the outer side, inner side will be hold on the lathe machine. For that purpose, we are using the 3-jaw chuck. See, chuck, 3-jaw. This 3-jaw chuck is also called it as another name is going to be independent chucks. We call it as independent chuck. 3-jaw independent. One is dependent, other we call it as independent. Dependent chuck. Dependent chuck. 3-jaw dependent chuck. If you are moving one jaw, all the other jaw will be moved. 4-jaw chuck is what we call it as independent chuck. Independent means individually it can move. One by one we can move individually, not all at the same time. And another is going to be collet chucks. Collet chucks. So if you are going for these chucks, chucks are used extremely holding for the workpiece or machining operation. Very large unusual shapes. Very large workpieces and unusual shapes also. Most commonly used chucks. Just I am showing the diagram. We will show elaborately what are the 3-jaw universal chuck, 4-jaw independent chuck, and collet chuck. 3 major chucks. 3-jaw, 4-jaw, collet. Right? 3-jaw chuck. What is 3-jaw chuck? Right? It is holds round the hexagonal workpieces. Hexagonal workpieces or the circular workpieces. Round holds circular or hexagonal or 3 sides. Triangular shapes workpieces we can fix in the 3-jaw chuck. This is a universal chuck. Commonly used chuck for all the machines. Grafts work quickly and accurately. 3-jaw moves simultaneously when you adjust the chuck key. Because if you are rotating one, all the 3 will go simultaneously. So we call it as dependent. One movement of the jaw, one jaw movement is dependent on other jaw. So all are moving at the same time. We call it as 3-jaw dependent chuck. We call it as 3-jaw dependent chuck. Or the 3-jaw chuck is also called as universal chuck. Universal chuck. So this is used for most commonly in the lathe machine. Most of the lathe machines we are using. Even student lathe we are using this type of jaws. 3-jaw chuck lathes. So next is going to be an 4-jaw independent chuck. Independent chuck means you can see here, if you are going for the previous diagram, if you are removing the one jaw, automatically other jaws will be removed. All the 3 jaws will be removed. But in case of independent chuck, 4-jaw independent chuck, each and every jaw can be removed separately. You can move each and every jaw independently. So if you are going for this one, this will be removed separately and this will be removed separately. This will be removed separately. So the one movement is not dependent on the other. So we call it as independent. Its own. Each jaw have its own power. So it having the, we call it as an independent. 3-jaw dependent, 4-jaw independent. Used for hold round. We can fix the round pieces, but the setting takes more time. square workpieces, hexagonal and irregular shaped workpiece. The major one, the 4-jaw chuck, is mainly used for irregular shaped workpieces. Irregular shapes workpieces has 4 jaws. It will have 4 jaws. The name itself says it will have 4 jaws. So it will be adjusted independently by the chuck key. One movement is not affected by the others. That is what we call it as independent chuck on the chuck key. The jaws can be reversed to hold the workpiece inside diameter. So see here, this won't be reversed. Instead of going inside, if you can reverse it, we can hold the hollow workpieces. We can hold the hollow workpieces in the 4-jaw chuck. In the 4-jaw chuck. All these chucks we have to move the chuck slowly, and then we have to adjust it for the proper center. For the proper center, and centering the workpiece takes more time. Centering the workpiece will take more time. And also these type of chucks are suitable for large diameter workpieces. Large diameter workpieces. So if it is very small diameter, these chucks may not be suitable. That time I will go for a collets. I will go for the collets. So how the chucks workpiece will be hold. We can hold the workpiece on the tail chuck spindle directly, because there will be a threaded nose. So we can fix. We can fix. This universal chucks will be fixed here with the screw on the tail stock spindle, headstock spindle, headstock spindle. That is why we call it as this is going to be a live center. This is going to be a live center, right? So next is going to be a tapered nose will be there. On the headstock spindle we will have the tapered nose. So just we can insert the most tapered centers. Just we can insert it. It will be locked. It will be locked. It will be locking system, self-locking system. So next one is going to be a cam operated, like a cam screw. See, this is going to be a cam. This is going to be a cam. Just we can adjust the cam. So the cam is having sacral profile. So it will go for a locking system. It will go for the locking system. So next one is going to be a collet chuck. Next one is going to be a collet chuck. These collet chucks are mostly used for holding the smaller diameter workpiece. If the workpiece diameter is very small, this type of collet chucks are used. This type of collet chuck. This is used mostly in tool rooms. Mostly in the tool rooms. So it is used for precision work. Spring collets available for round, square, hexagonal, shaped. There are different shape sizes are available. And this collet chuck will have different ranges. If it is 10 mm, there is another collet chuck for 10.2 mm, 10.3 mm, 10.5 mm, 10.6, 10.7, 10.8. It ranges, different ranges, thousands of ranges are there to hold different sizes of workpieces. This is suitable for smaller diameter workpieces, and also fixing is easy. Fixing is easy. And removing of workpiece is also easy in case of the collet chucks. See how many varieties are there for smaller diameter to the larger diameter. After that, there are different varieties are there holding the different sizes of workpiece. Small pins will be there for locking system, for tightening the workpiece. It is going to be a very precision, high precision works. We can use for the tool rooms lathe. We can use this in capstan turret lathe. All the lathe they are using for bar feeding mechanism. These chucks are easily we can hold. We can operate by the pneumatic system also. We can operate it by pneumatic system also. So this is what we call it as collet chucks. See the collets how it was inserted. See the front. Just they can press it. Just they can press it. The special adapter is fitted on the taper of the headstock spindle, and hollow drop bar into an internal thread inserted to the opposite of the headstock. It draws a collet tapered adapter using the collet to tighten the workpiece. Taper adapter. As a taper adapter, as I discussed, it is going to be self-locking. It is going to be self-locking. Then if you are rotating this hand wheel, just it can push it this side. Here it will push. Once if you are pushing, the collet will come out easily. Collet will come out easily. Next, if you want to fix a workpiece, just we can press it. Then hold the workpiece automatically it will tight. We grip the workpiece. For that purpose, we are using the collet chucks. So next one, we will see how the collet is again. See the front. The collet is holding the workpiece. Collet is holding the workpiece. These are the splits. Just pressing. Just pressing. Spindle adapter. Spindle adapter. The spring collets are there. So this is where it was included. These things for your knowledge purpose. In the examination, just you can write only the what do you mean by collet chucks. Collet chucks are used to hold the precision workpiece. They are available in different ranges. It is having the most taper. So because of the most taper, it can be easily fixed on the spindle. And by rotating the hand wheel of the spindle, it can be easily removed. Right? So because of that, loading and unloading of the workpiece will be easier. Loading and workpiece unloading of the workpiece will be easier. So that is what we call it as lathe chucks. So next is going to be a lathe dogs. Lathe dogs, which is used for rotating the workpiece, which is used for holding the workpiece. Cylindrical workpiece, if you want to do some of the taper turning operation or the plane turning operation, these dogs are used, drive dogs are used. The workpiece is fixed in this dog, in this dogs, right? Device clamps around the workpiece and allows the rotary motion of the machine spindle to be transmitted to the workpiece. So in this, if we are using the dogs, the motor rotating, right? Like motor is rotating. If the motor rotating, the spindle of the headstock is rotating. When the headstock is rotated, the power is transmitted to the driving dogs. Then it is going to the workpiece. So spindle to the dog to the workpiece. Right? The carrier most usually for turning between the centers of the lathe. It is used for performing the operation in between centers of the lathe. If we are using the dogs, we need the faceplate. Otherwise, we cannot able to use this particular dogs. Dogs is used along with the faceplate. Right? So lathe dogs. Next is going to be in types of dog. Types of dog. The types of dogs are going to be in two types. One is going to be in bent tail. If it will be like this, right? At the top there will be a bend. There will be a bended. And another one is going to be in straight tail. This will be a straight one. It will be like a straight. See the first one. This is going to be a straight one. And second one, if you see, there will be a bend. There will be a bend. Straight dog as well as bended dog. Most commonly used for round workpieces, available square-headed set screws of headless set screws. See this headless set screws. There will be screws. Straight dog, driven by the stud and the drive plate, by using the driving plate, used in precision turning. Used in the precision turning process. Right? For this, we are using the lathe dogs. Right? Next one, see this. How these dogs are used. Different types of dogs. Right? Safety clamp lathe dog. Safety clamp. We are using the clamps. These are all the clamps. This is a clamp. This is a clamp. There is a bend. So by using this, we can hold the circular workpiece. We can hold the square workpieces. We can hold the square workpieces, which can be turned in between the centers. Compared to four-jet chuck, these type of dogs are very easy. Very easy. Safety clamps. Right, used to hold a variety of work, wide range of adjustment. There is no restriction of shape. Maybe a square, maybe a rectangle, or maybe a hexagon, maybe a octagon, whatever may be the shape, we can go. Clamping lathe dog, wide range other than all the other shapes. These are the different types of dogs are used. See, the workpiece is held between the centers. Then this is going to be the dog. The workpiece is held on the dogs, fixed on the dogs and the center. So this is what we call the slotted faceplate. Slotted faceplate. So by using this, it will be driving. It will be driving held between the centers, right? And see another how it was held between the center by using the clamping dogs. This is what we call it as a clamping dogs. So this is getting the power. The spindle is getting the power. So this faceplate is rotating. So the dog is also rotated along with the workpiece. So held between the centers. Next is what we call it as faceplate. What we call it as a faceplate. This faceplate is a circular one. Faceplate is a circular one. It is as in basic work holding devices in the lathe machine. It is circular metal plate which fix the end of the lathe spindle. It is fixed on the lathe spindle. Fixed on the exact lathe spindle. The workpiece is then clamped on the faceplate. Workpiece can be clamped on the faceplate by using the slots. We can use the bolt and nut. We can clamp the workpiece. Typically T-nuts. T-bolt are used for slot in the faceplate. It's less commonly threaded hole in the faceplate itself. They cannot directly threaded. This faceplate having the thread, it can be threaded onto the spindle. Screwed on the spindle. Then this faceplate is rotating. In this faceplate, we can fix the workpiece. Square, rectangle, maybe some hexagonal, whatever will be the shape that can be clamped by using the bolt and nut. Or else drive plates will be attached with these slots that can be rotated. Faceplate. So next is going to be how the faceplate is. See this. This is the workpiece. This is the workpiece. This is the clamping dogs. Right? Hold down clamps. That just we are going to put the clamps. We can tighten it. So many bolts are the clamping mechanism. They are clamping it and then they are doing the internal operation or the external operation, equipped with several slots to permit the bolt to secure the workpieces. Secure the workpieces. This is called as a faceplate. And driving plates. The driving plate is like a same like a faceplate, that is also screwed to the spindle. So in this slot we can put the driving dogs. So if you are putting the driving dogs inside it, so this is rotating, so the drive dogs will be rotating. See here, it is inserted inside the plate, drive dog. So if you are rotating, so this plate is also rotating. So this is rotating, just what we call it as a drive plate rotates, dog rotates. Once the dog rotates, this workpiece starts rotating. Workpiece starts rotating. That is what we call it as a drive plate. The next is going to be a steady rest and follow rest. Next is what we call it as steady rest and follow rest. What is steady rest? What is follow rest? So when you are performing the longer workpieces in the lathe machine, what will happen? The longer workpieces, because of its own self-weight, it will start sagging. It starts sagging. So because of the sagging, I cannot perform the work effectively. We cannot able to turn the workpiece, or we are not able to make the thread on the workpiece. Because of that, what I am going to do is, I am going to give the support to avoid the sagging movement. To avoid the sagging movement, we are going to give the support. So that support avoids, restrict the momentum of the workpiece in the sagging. The workpiece cannot be permitted to go for sagging. That workpiece is rested. The workpiece will be rested on this particular rest. That is what we call it as steady rest. That is what we call it as steady rest, or we call it as a rest. What we call it as a rest, because the workpiece is rested. If the workpiece is rested, there is no bending moment. There is no bending on the workpiece because of its own self-weight. So longer workpieces, we can use this steady rest or follow rest. Steady rest or the follow rest. Two types of rest are there, steady rest and follow rest. Or the steady rest, we can name it as a fixed rest. Fixed rest, or we call it as fixed steady. Steady rest, fixed steady, or steady rest, all will have the same meaning. If it is used for holding the long workpieces, which is held on the chuck between the centers, prevent the springing. Springing means is a sagging. Located aligned by the base of the lathe. It is located on the lathe guide base. Lathe guide base. Position at any point on the lathe machine. We can keep it at any point because it is fixable. It's a fixed center, so we can clamp at any position. It will be clamped. It will be clamped. There will be three jaws like this. Three jaws will be there like this. So in between the three jaws, this will be there one jaw, another will be another jaw, another will be another three jaws. So these three jaws will clamp the workpiece. Three jaws will clamp the workpiece. Right? So clamp means not clamping completely. It's just a point contact, but it can revolve. It can revolve. The position at any point on the long bed. Three jaws are tipped with plastic. Bronze roller may be adjusted to support the diameter. Steady rest capacity. Steady rating capacity. Steady rest capacity. That is what we call it as steady rest. But even if you are going for steady rest, for longer workpieces, it is rested at only one point, at only one place. Even though there is a possibility of, even though we are resting at one point, there is a possibility of sagging. So that can be avoided by using the follower rest. The rest is following along with the workpiece. It is fixed near to the tool, next to the next tool as well as rest side by side. So when the tool is giving the force, the workpiece tries to bend. So that can be avoided by giving the opposite reaction. Opposite side, there is a support. So if we are giving the opposite support, that's come through the follower rest. That comes through the follower rest. See the follower rest. See, this is a steady rest. So see the support. It is fixed at one end. Fixed at the one end. It cannot be moved along with the tool. Even if you are forcing here, there may be a possibility of bending. Right? So see this steady rest. So this will be inserted in between the workpiece will be inserted in between three jaws. So we are tightening this one. So workpiece is freely rotated. This is a roller. This is the roller. This roller permits the free movement. It is not fixing rigidly, and it will not damage our piece also. That is what we call as steady rest. And another one is what we call as a traveling rest or the follower rest. Traveling rest or follower rest. As we already discussed, this traveling rest or follower rest is next to the tool, fixed on the saddle, mounted on the saddle. Where the saddle is fixed, it is on the garage. It is on the garage. The tool post is also fixed on the saddle. So the rest is also fixed on the saddle. So once we are moving the garage, this one is also follower rest also moves along with the garage, along with the tool. Right? The cutting tool generally position next ahead of the follower rest. Prevent the smooth bearing face of 2 jaws on the follower rest. 2 jaws of the follower rest. Previously there will be 3 jaws. In case of the follower rest, we will have the 2 jaws. One side is open. So it will follow continuously along the workpiece. So the springing effect will be removed. Right? So see here how it is. See this one. So there is a workpiece will be there. There will be a rest which will be fixed on the saddle. So once if we are moving the garage, the saddle is also moves. The tool is also moves. So the workpiece along with the workpiece. So the tool and rest is moving at the same time. Both are following. The tool follows the rest. So that is why we call it as follow rest. The tool is traveling along with the rest. We call it as traveling rest. Traveling steady. Right? See another way. How it will be rested. The workpiece will be rested by the carbide tip tools. Carbide tip centers. Traveling steady. Right? Mantles. These mantles are used to hold the hollow workpieces of larger diameter also. Hollow workpieces of larger diameter. Because the work cannot be holded in between the centers if there is a smaller width. In the holding chuck itself, we need 2 centimeters. Even the workpiece's width is only 2 centimeters. How we can perform the operation? We cannot perform. That case, we can use the mantles. Mantles is nothing. It is going to be stepped job, like a step turning the lathe machine. The holes internally machined workpieces between the centers. So further machining operation carried. Operations are concentric with the bores, concentric circles with the bore. Several types of mantles are there. One is going to be plain mantle, expanded mantles, gang mantle, stub mantles. 4 types of mantle. Plain mantles is only one job we can fix. Expanded mantles, it is automatically expands. We can hold the different diameter easily. Gang mantle means many jobs, maybe 3 jobs, 4 jobs will be fixed on the same mantle. So it is what we call as gang mantles. Another one is going to be stub mantle. Stub barber like that. At the end we are fixing stub mantles. So see this one. So this is going to be a mantle, hollow shaft. Right? The shaft will be there. Solid shaft is there. The workpiece 1, 2, 3, 4 workpieces. This is a mantle. This is a mantle. This mantle is fixed with the dogs. That dog is driven by the faceplate or the drive plate. This is what we call as plain mantles. Right? So if you are going for the plain mantle, see here how the operations are performed. So if you are going for this mantle, this expandable mantle, self-expandable mantle. So see this one. There will be a steps. So by rotating these steps, we can expand. Automatically. It can expand automatically. So we can hold different size of the workpiece. Just it will open this like by using the chisel, just chip it, and then it will open it, it will expand. Then again if you can open and then close it, it will close. It is what we call as expanded mantles. Next is what we call as gang mantles. Gang mantles, many workpieces. 1, 2, 3, 4, 5 workpieces will be fixed at the same time. We call it as gang mantles. So next is going to be stub. At the end we are fixing. We call it as stub mantles. So one is going to be first one we call it as plain mantles. Right? The simple hole shaft will be there. The same diameter, internal diameter piece will be held, and the expandable mantle for easy removal we are expanding for holding the different size of workpiece. Next one we will go for gang mantles. We can fix many number of workpieces at the same time. We call it as gang mantles. Next is going to be stub. At the end we are fixing what we call it as stub mantles. So next is going to be what are the methods we are using for cutting the tapers in the lathe machine. What are the methods are used for cutting the tapers in the lathe machine? We will see in the next class what are the different types of tapers and how the taper turning operation is performed on the lathe machine. Thank you very much. We will meet in the next class.